Welcome back, students, in a new chapter where we are going to discuss about heat and energy. This is the sixth chapter of our course book, and over here we are going to discuss about heat and temperature. Then we will understand about the thermal expansion, anomalous expansion of water, Hope's experiment related to the thermal expansion of water or the anomalous expansion of water. Then we will see for the consequences of the anomalous expansion of water, and at the end we will come to know about the energy flow and the different forms of energies which we use in our day-to-day life. So let's start with it. The first thing which we need to understand, that is, let's recall those things which we had studied in our previous classes. So when we talk about heat, then what does that mean and how we can define for it? When you used to touch any kind of hot object, or when you touch any cold object, such as, for example, if you will take a piece of ice in your hand, you feel cold over there. Or if you touch the burning candle, then you feel warm over there. What does this means? This means that it is hot or cold. So when we are talking about heat, then heat is actually a kind of energy that any matter do used to have inside it, and that is because of the molecular motion. So basically we say this thing that heat is a form of a kinetic energy which is due to the random motion of the molecules in any given substance, and that generates or that causes the heat energy in that body or in that object. जब भी हम लोग किसी भी तरह के मैटर के बारे में बात करते हैं, तो हम लोगों को ये पता है कि उस मैटर के अंदर पार्टिकल्स होती हैं और उन पार्टिकल्स की एक अरेंजमेंट होती है। और जैसे कि हम लोगों ने पहले भी पढ़ा हुआ है, सॉलिड, लिक्विड और गैस, ये तीन बेसिक स्टेट्स हैं मैटर के, और इन तीनों स्टेट्स में हम लोग पार्टिकल्स की अरेंजमेंट को ऑब्जर्व करते हैं। सॉलिड्स में पार्टिकल्स बहुत नज़दीक होते हैं, लिक्विड में पार्टिकल्स थोड़े से दूर होते हैं, गैसेस में पार्टिकल्स और दूर होते हैं। और इसके कारण यहाँ पे जो जो इंटरमॉलिक्यूलर मोशन है या फिर काइनेटिक मूवमेंट ऑफ द पार्टिकल्स है, ये अलग अलग होती हैं। यही यहाँ पर हीट एनर्जी को डिफर करती है। जब हम लोग देखते हैं किसी मैटर के बीच में, पार्टिकल्स के बीच में स्पेस ज्यादा है, तो वहां पर वाइब्रेशन ज्यादा होती है। इट मींस दैट दे डू हैव मोर एनर्जी ओवर देयर। सो दैट इज द बेसिक थिंग व्हिच वी नीड टू अंडरस्टैंड फॉर गोइंग फॉर द हीट। सो व्हेन वी आर टॉकिंग अबाउट हीट, हीट इज एक्चुअली द रैंडम मोशन ऑफ द particles that any matter used to have, or any matter do passes over there. Now, when we say about the internal energy of the particles, that gives the heat energy. So over here you can see that I had given the definition, or a simple explanation. In physics, heat is considered as a form of existing as the result of the random motion of the molecules, and is in the form of energy that is transmitted between the bodies as a result of their temperatural difference. सो बेसिकली ये है क्या, सीधे सीधे शब्दों में अगर हम लोग कहें तो हम लोग ये कह सकते हैं कि हीट एक इस तरह का एनर्जी है जो कि किसी भी मैटर में होता है ड्यू टू द रैंडम मूवमेंट ऑफ द पार्टिकल्स। और इसके कारण या इस फेनोमिना के कारण अगर हम लोग किसी भी दो मैटर को डिफरेंशिएट करते हैं, तो हम लोग वहां पर ऑब्जर्व कर सकते हैं कि किसी मैटर में ये मोशन ज्यादा है और किसी मैटर में ये मोशन कम है। or because of that we will observe this thing that energy gets transferred from one to another. So that is the basic concept of heat, और इसी को हम लोग heat को बोल सकते हैं या फिर heat को define कर सकते हैं। जब हम लोग heat को और explain करते हैं तो हम लोग कहीं कहीं पर heat को as a thermal energy के रूप में भी समझते हैं। So what does this thermal energy means? Thermal energy, you can say it is the internal energy that any matter do used to have, and that internal energy is because of the sum of the potential and kinetic energy that the particles of that matter used to possess. So किसी भी मैटर के जो पार्टिकल्स हैं उसके अंदर जो पोटेंशियल और काइनेटिक एनर्जी का जो सम होता है, वो उसके थर्मल एनर्जी या इंटरनल एनर्जी को एक्सप्लेन करता है या दिखाता है। तो जब हम लोग हीट एनर्जी के बारे में बात करते हैं तो उसको हम लोग थर्मल एनर्जी और इंटरनल एनर्जी के रूप में भी डिफाइन कर सकते हैं, जहां पर हम ये कह सकते हैं कि इट्स इंटरनल एनर्जी इज एक्चुअली द सम ऑफ द टोटल potential and kinetic energy of the particles which is present over there at that particular condition. And if the condition gets changed, then the thermal energy can also be changed, means the amount of the potential and kinetic energy can also be altered, and with the change of that amount there will be some other kind of changes. Now over here when we study about heat, then we also come to know about these two terms. हम लोगों को हीट से रिलेटेड ये दो टर्म्स को समझने की जरूरत है, जिसको और डिटेल में हम लोग अपने हायर क्लासेस में डिस्कस करेंगे. सो कैलोरीमेट्री, व्हाट इज कैलोरीमेट्री? कैलोरीमेट्री इज द मेजरमेंट ऑफ द क्वांटिटी ऑफ हीट. सो जब हम लोग हीट को कैलकुलेट करते हैं, हीट की स्टडी करते हैं, तो वहां पर हम लोग कैलोरीमेट्री को समझते हैं. सो कैलोरीमेट्री is the calculation by which we can measure the amount of heat that is present in any body. So there is a particular calculation, or there is a method by which we can do this thing. Next thing which we come across while we study about heat, that is the thermodynamics. So thermodynamics is the study of the heat and its transmission as in the form of the mechanical energy. तो जब हम लोग ये समझते हैं कि heat energy जो है वो किसी भी मैटर के इंटरनल एनर्जी है, यानी उसके उसके अंदर के काइनेटिक और पोटेंशियल एनर्जी का सम है. तो अगर हम लोग दो अलग अलग बॉडीज को लेते हैं, जैसे कि फॉर एग्जांपल अगर कोई हॉट बॉडी है और कोई एक कोल्ड बॉडी है, तो हम लोग इजीली कंपेयर कर सकते हैं कि हॉट बॉडी के अंदर जो इंटरमॉलिक्यूलर मोशन होगा वो कंपैरेटिवली ज्यादा होगा किसी कोल्ड बॉडी के कंपैरिजन में. तो अगर उन दोनों बॉडीज को आमने सामने रखा जाए या इन कांटेक्ट रखा जाए, देन वी विल ऑब्जर्व दैट द एनर्जी विल बी ट्रांसमिटेड फ्रॉम द हायर रीजन टू लोअर रीजन. So when we are studying about this or concepts related to this, then that comes under the study of thermodynamics. So these things, as I said, we will discuss in detail when we will go for the next class, means in class 10th we will discuss more on this thing. Now over here we have to also go for the SI unit of heat. जब हम लोग heat पढ़ते हैं as a form of energy, then we need to remember this thing that the SI unit of energy is joule. Hence, the heat's SI unit is also joule. But there are some other conditions where do we observe that heat is also been represented as a form of a calorie. यानी हीट को हम लोग जूल के रूप में तो दिखा सकते हैं, क्योंकि हम लोग ये डिफाइन करते हैं कि हीट इज अ फॉर्म ऑफ एनर्जी. And when it is a form of energy, then obvious thing is that as the SI unit of energy is joule, so we will use the SI unit of heat also as joule only. But कुछ ऐसे कंडीशंस हैं जहां पर कि हम लोग हीट के लिए एक अलग यूनिट को भी रिप्रेजेंट करते हैं, जो कि कैलोरी के रूप में होती है. तो हीट को कैलोरी के रूप में भी कई सारी जगहों पर एक्सप्रेस किया जा सकता है. What does this calorie means actually? So 1 calorie is equals to around to be 4.186 joule, which can be taken as in the round up form as 4.2 joule. And this is the amount of energy that is required by 1 gram of water to raise its temperature by 1 degree Celsius. तो जब एक कैलोरी यूनिट को हम लोग कैलकुलेट करते हैं या मेजर करते हैं, तो हम लोग ये कह सकते हैं कि ये वो अमाउंट ऑफ एनर्जी है जो कि 1 ग्राम ऑफ वाटर कंज्यूम करता है, या फिर 1 ग्राम ऑफ वाटर लेता है उसके 1 डिग्री सेल्सियस को इंक्रीज करने के लिए. वैसे तो हम लोग किसी भी दूसरे टेम्परेचर को ले सकते हैं इसके डिफरेंस को समझने के लिए. सपोज फॉर एग्जांपल 20 to 21 डिग्री सेल्सियस और 10 to 11 डिग्री सेल्सियस, बट इट बीन फाउंड साइंटिफिकली दैट इट इज वेरी मच good, or it is very much recommendable that if we will take the difference of 1 degree Celsius between 14.5 degree Celsius to 15.5 degree Celsius, अगर हम लोग 14.5 डिग्री सेल्सियस से 15.5 डिग्री सेल्सियस के बीच के डिफरेंस को लेते हैं, तो ये हम लोगों के लिए एक बेटर कॉन्सेप्ट को क्लियर करने के लिए, या फिर एक साइंटिफिकल मेथड के रूप में हम लोग इसको रिप्रेजेंट कर सकते हैं. सो व्हेन यू नीड टू डिफाइन फॉर 1 कैलोरी ऑफ एनर्जी, देन यू कैन से दैट 1 कैलोरी ऑफ एनर्जी इज द अमाउंट ऑफ हीट एनर्जी दैट इज रिक्वायर्ड टू इंक्रीज द टेम्परेचर ऑफ 1 ग्राम ऑफ वाटर बाय 1 डिग्री सेल्सियस, over where we take this difference of 1 degree Celsius between 14.5 degrees Celsius to 15.5 degrees Celsius at a particular condition, and over here the pressure used to be remain constant. So that was the unit of energy. Now let's understand about temperature. See, whenever we are studying about heat, temperature is a thing which comes along with that one. So what does this temperature means? So basically we can define for this thing that the temperature is the measure of hotness or coldness of any matter. जब हम लोग किसी भी मैटर को एक्सप्रेस करना चाहते हैं कि वो कितना गर्म है या कितना ठंडा है, तो उस जगह पर हम लोगों को ये ध्यान देने की जरूरत होती है कि उसको एक मेजरेबल एक्सप्रेशन करना होता है, यानी एक इस तरह के न्यूमेरिकल पैटर्न में लेकर जाएंगे जिससे कि हम उसको एग्जैक्टली बोल सकते हैं कि अगर वो गर्म है तो कितनी गर्म है, अगर वो ठंडा है तो कितना ठंडा है। तो इस तरह से हम लोग उसको आइडेंटिफाई कर सकते हैं एक बेटर तरीके से। So to make it study in a proper way, or to make the condition in a proper way, we go for an exact numeric value. And for that numeric value, we put it as temperature. So temperature is actually the denotation of a body, that how hot or how cold that is. Or you can say temperature is the denotation of the average kinetic energy of the particles of that substance. Because see, if the particles do have more kinetic energy, अगर particle किसी मैटर के particles में ज्यादा kinetic energy होगी, सो ऑब्वियस सी बात है कि वो कंसीडर किया जाएगा कि वो एक हॉट ऑब्जेक्ट है। और अगर वो हॉट ऑब्जेक्ट होगा तब ऑब्वियस सी बात है कि उसकी टेम्परेचर भी हायर होगी। और अगर किसी किसी बॉडी के पार्टिकल्स की जो 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 मूवमेंट है वो स्लो है, वो धीरे धीरे हो रही है, then it means that it is comparatively cold object, and if it is so, then its temperature will also be low. So we can say both the things, that temperature is the denotation of how hot or cold, or it gives the measure of the hotness or coldness of any body, or we can say that it is the calculation of the average kinetic energy for the particles for any kind of matter. So for any matter, that is the denotation. So इससे हम लोग उसको denote कर सकते हैं। With this one, we need to also remember this thing, that the SI unit of temperature is Kelvin, and two other common units which we use to express the temperature, that is degree Celsius and Fahrenheit. But these two are not the SI unit. The SI unit of temperature is Kelvin. So I hope that you all remember what we had done in our previous classes, while we had done for the conversion of degree Celsius to Fahrenheit, Fahrenheit to degree Celsius, in the same way degree Celsius to Kelvin, and Kelvin to degree Celsius. So all these relations which we had already done in our junior classes. So I'm not going for those calculations over here. Now, again, as what I was discussing earlier, that what we can say for the temperature. So I had gone for some explanation over here. So basically, this is the same explanation what I had explained earlier, where I was discussing this thing, that the temperature can be denoting the kinetic energy of any matter. So जब हम लोग किसी भी matter के kinetic energy को define करते हैं, तो उसको temperature के basis पर दिखाया जा सकता है. So if the particles are having very high random motion, or we can say if the particles do have more kinetic energy over there, then obviously it will show that it has a higher temperature. And if the particles are slower over there, if the particles are moving very slowly, it means that it don't have much kinetic energy over there, then it will be considered to be as a low in temperature. So the temperature is the denotation of the physical state of a matter with respect to the molecular arrangement. If the molecules are randomly vibrating, or if the molecules are having high amount of kinetic energy, then its temperature is more, and if it is not, then its temperature is low. So we can observe this thing with one more thing, that when we do supply heat to any body, then we observe that there is a gradual increase in the temperature. Or when we cool down a body, then also we observe that there is a drop in temperature. So while we are heating or while we are cooling, we are actually changing the intermolecular kinetic energy. So if we are supplying heat to the body, then we are increasing the kinetic energy. So with that one, we will observe that there will be a gradual increase in the temperature. But if we are taking out heat, means if we are cooling the body, then we drop down, or we decrease down the kinetic energy of the particles, and due to this we used to observe that the temperature also falls down. तो अगर particles के intermolecular motion को अगर हम लोग बढ़ाते हैं, अगर वहां पे particles अगर ज्यादा vigorously vibrate करने लगते हैं, जैसे कि किसी भी बॉडी को जब हम लोग हीट करते हैं, तो पार्टिकल्स वहां पर वाइब्रेसली वाइब्रेट करेंगे, इसका मतलब होगा कि उसका काइनेटिक एनर्जी इंक्रीज कर रहा है। और अगर काइनेटिक एनर्जी इंक्रीज कर रहा है, तो इसका मतलब ये है कि वहां पे टेम्परेचर में भी हमको इंक्रीज होता हुआ दिखेगा। और दूसरी तरफ वाइस वर्सा फॉर्मेट के रूप में अगर हम लोग देखते हैं कि अगर हम लोग किसी बॉडी से हीट को एब्जॉर्ब कर लेते हैं, मींस अगर हम लोग किसी बॉडी को कूल डाउन करते हैं, तब हम लोग वहां पे देखेंगे कि जो पार्टिकल्स की जो वाइब्रेशन है या फिर जो पार्टिकल्स की जो काइनेटिक एनर्जी है वो कम हो रही है, और बिकॉज ऑफ दिस व्हाट वी विल ऑब्जर्व दैट द टेम्परेचर ऑल्सो फॉल्स डाउन. सो दिस इज द रिलेशन विच वी नीड टू रिमेंबर. Now let's understand about the effect of heat energy. So again, these effects we had done in our junior classes. So just for a simple recap of that what we had done earlier. So there are various effects what we can observe or what we used to see in our day-to-day life due to heat energy. The very first thing we can see over there that due to heat energy there is a change in the temperature. So when we are supplying heat to a body, then we used to observe that the temperature rises. As just now we were discussing over here that when we are heating any body, means we are giving energy to it. And when we say that we are giving energy, then we are actually making the particles vibrate vigorously. And when we are making the particles vibrating over there, means we are increasing the kinetic energy of the particles. Obviously, we will observe that temperature will increase over there. And same thing will be observed in a reverse way if we will cool it down. The next effect which we need to remember that due to heat, we can observe that different kinds of chemical changes can be occur. So there are several examples where you can see that the heat is required to perform a chemical reaction. So in chemistry, you may have seen that there are so many chemical reactions taken place between so many different things where heat was used as a catalyst, or heat was used as a component which helped the chemical reaction to be performed. So chemical reaction can be took place due to supplying of heat. Next, we can see this thing that due to supplying heat, we can make any body to catch fire. So अगर कोई ऐसी ऑब्जेक्ट जिसको हम लोग हीट कर रहे हैं और वो हीट को अब्सॉर्ब नहीं कर सकता है, हीट को अब्सॉर्ब करने का मतलब वो हीट को ट्रांसफर नहीं कर सकता है. So under that condition, what will happen that the particle will take the heat, and with the giving of heat, or with the continuous supplying of heat, slowly its internal temperature will rise up, and when it will meet to its ignition temperature, then it will catch fire. So mostly we will observe this particular phenomena going through with insulators. So those kind of components which doesn't allow the heat to be transmitted from one end to another end, they used to increase their temperature on receiving heat, and after reaching to a particular limit, or after reaching to a particular temperature, they are not able to bear to hold the heat, and thus they start burning. So this is also a condition or an effect which we used to observe due to supplying heat. तो अगर हम लोग heat supply करते हैं, तो वो matter अगर वो heat को absorb नहीं कर सकता है या उसको transmit नहीं कर सकता है, तो वो क्या करेगा, वो उसमें उसमें आग पकड़ लेती है. So this is also one of the very important factor, or sorry, effect for the heat. Now the next one which we have to see over here, that on heating, change of the state of a matter. This is a very common thing which you had already studied from your very junior class, that when we are supplying heat to matter, again over here also we need to remember that this can be observed for the conductors only. So not all matter used to change their state on supplying heat. Only there are some or few matters who are conductors, they can be able to change their state from one to another on supplying heat. तो अगर हम लोग जैसे कि फॉर एग्जांपल अगर लिक्विड वाटर लेते हैं, अगर उसको हम लोग गर्म करते हैं, वी कैन चेंज इट इनटू गैसियस फॉर्म, and if we cool that water, then we can change it into solid form. So this is the phenomena which we used to observe, that on supplying heat we can change the state from solid to liquid and liquid to gas. Vice versa, if we are cooling the body, then we will observe that we can change the state from gaseous to liquid and then liquid to solid. So these are the things which we had already understood. Now the next thing and the last one which we used to over here, that is that when heat been supplied, then we can change the shape and size of a body. So on supplying heat, we can observe this thing that we can change the shape and size. Means either we can expand or we can contract with the change in the amount of temperature over there. So if you are supplying heat, अगर हम लोग किसी चीज को गर्म करते हैं, again this phenomena can be observed for the conductors only. So अगर हम लोग कंडक्टर्स में हीट सप्लाई करते हैं, then because of the increase in the gradual increase in the kinetic energy, we do observe that the matter used to expand. वो expand करता है वहां पर, और जैसे जैसे वो expand करता है, we used to observe that the size used to change. On the other hand, if we are cooling it down, then we do observe that the drop down of kinetic energy of the particles, the matter shrinks down or it contracts, and because of that also we used to observe that the body used to change its shape and size. So due to supplying of heat, we can observe expanding condition or the contracting condition. So these things we had also studied earlier. Now students, in this class, basically as I was as I was explaining in the beginning, that we were going to see for the anomalous expansion. So expansion is one of the things which we are going to understand in this particular class. So in class 8 we had came across the expansion in solids as well as in liquids also a little bit. So while we go for the solid body, those which can supply heat and those who can go for expansion, over there we can see that if the body used to change its length only for only one sided, if length is changing, then we will say that there is a linear expansion. So this can be done for a rod like structure. So length used to change while we used to heat the body. While if the body is in a form of thin metallic sheet, if suppose this thing, a sheet of metal is there, and if we supply heat from the middle, then we used to observe that that there is an expansion through along its length and breadth, and because of that the area used to change, so which is called to be as the superficial expansion. And if it is a thick metallic body, then we used to observe that there is an expansion along its length, along its breadth, as well as along its height. So three-dimensional expansion used to be there, and because of this the volume used to change, so that is known as the cubical expansion. So this we had already studied in class 8. And over here is there is a concept where we are going to discuss about the expansion in liquids. So not only the solids used to expand, the liquids also used to expand. See students, basically when we go for the expansion, it is actually the change in the kinetic energy of the particles. देखो, हम लोगों ने स्टार्टिंग में ही ये समझा है कि जब हीट सप्लाई किया जाता है तो काइनेटिक एनर्जी, जो पार्टिकल्स की काइनेटिक एनर्जी है या एवरेज काइनेटिक एनर्जी जो है वो वहां पर चेंज होती है। तो अगर हम लोग हीट सप्लाई किए और हीट सप्लाई करने के बाद काइनेटिक एनर्जी इंक्रीज होने लगती है, तो एट अ टाइम वहां पर मैटर के स्टेट में चेंज नहीं आता है। सबसे पहले मैटर के पार्टिकल्स के बीच में थोड़ा सा स्पेस क्रिएट होता है, और ये जो स्पेस क्रिएट होता है इसी के कारण हम लोग एक्सपेंशन देख सकते हैं। ठीक इसी तरह से अगर हम लोग किसी मैटर को ठंडा करते हैं, अगेन आई एम टॉकिंग अबाउट कंडक्टर्स ओनली, आई एम टॉकिंग अबाउट बेसिकली कंडक्टर्स ओनली। तो जब हम लोग उसको ठंडा करते हैं तो हम लोग ये ऑब्जर्व करते हैं कि पार्टिकल्स जो कि पहले दूर भाग रहे थे अब नजदीक आ रहे हैं, क्योंकि उनका 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 जो काइनेटिक एनर्जी था वो डिक्रीज करने लगा। जैसे ही उनका काइनेटिक एनर्जी डिक्रीज करता है, इंटरमॉलिक्यूलर अट्रैक्शन फोर्स ज्यादा इंपैक्ट करता है वहां पर, जिसके कारण वो पार्टिकल्स नजदीक आते हैं, और इसके कारण ही हम लोग कॉन्ट्रैक्शन देखते हैं। तो चाहे हम लोग सॉलिड्स के बारे में बात करें या लिक्विड के बारे में बात करें या गैसेस के फॉर्म में बात करें, हर जगह पे हम लोग को एक्सपेंशन देखने को मिलेगा। लेकिन अगर हम लोग बात करते हैं with the same amount of change in the temperature, then we will observe that the gases used to expand more than to liquid and solids. Why? Because over there particles are already very much far away from each other. So with a little bit amount of heat which we are supplying over there, it makes the particles energetic, and because of that they rapidly move away from each other. They break down their intermolecular attraction force and they go far away from each other. So expansion can be observed in all the state, but it can be observed maximum in gases, then in liquid, and then we will observe in solid. So over here there is an example where you can see that I had used four different kinds of liquids, and over there also we can observe that the expansion is different. So you can see that benzene can expand more than compared to any other liquid, at the same temperature with the same mass. Okay, so over here in this experiment, benzene is expanding more. So you can see that the liquid level is at the top, and over here alcohol is expanded to a little bit high, and the kerosene is also a little bit less than to alcohol, and water is expanding very much less. And one of the reason of this thing that while we observe this thing that water do have minimum expansion, because water do have high specific heat capacity, because of which it has a tendency to absorb a large amount of heat than compared to any other liquid. So that we will discuss in class 10 syllabus. So specific heat capacity of water. Now over here, as I was discussing that why do we observe the thermal expansion due to change in the heat. जब हम लोग थर्मल एक्सपेंशन के बारे में बात करते हैं तो वहां पर असल में हम लोग वॉल्यूम में चेंज को देखते हैं। जब हीट सप्लाई की जाती है सो हीट के साथ साथ वॉल्यूम में चेंजेस आती है, एंड विद द चेंज इन द वॉल्यूम वी विल ऑब्जर्व दैट देयर विल बी अ चेंज इन द डेंसिटी आल्सो। सो दिस आल्सो यू नीड टू कीप इट इन माइंड, as you all know this thing that the density of any matter is equals to mass upon volume. Now with this one you come across this thing that the density is directly proportional to mass, and the density is inversely proportional to volume. So what does this means? This means that if the mass is increasing then the density will also increase, and if the mass will decrease then the density will decrease. For this condition where we observe that the density is directly proportional to mass. On the other hand, we used to observe this that the density is inversely proportional to volume. So what does this mean? This means that if the volume is increasing, then the density will decrease, and if the volume decreases, then the density increases. So it goes in reverse phenomena. So when we are heating the matter, means for the conductors, again I'm telling for this thing. So when we are heating it, we used to observe that particles go away from each other. And when the particles are moving away from each other, volume increases. And as the volume increases, what happens? The density decreases down. So this is one of the this is one of the effect which we used to observe due to the condition of expansion. Now, let's understand about the anomalous expansion of water. See students, to understand the anomalous expansion of water, we have to understand this particular concept. So hence again I'm repeating for this thing, and then I will go for the anomalous expansion. Here we had understood that if we are increasing the temperature, as the increase in temperature, we do observe that the volume increases. The volume of the material means the volume of the material also increases. So as the volume of the material increases, we will observe there will be a decrease in density. There will be a decrease in the density of the material. Okay. And the vice versa condition we will observe if we do the reverse thing. Means if we are cooling it, then we will observe the reverse thing. Means if we are cooling, then we will observe that the intermolecular attraction force will increase over there, because the particles will come closer to each other. And as the particles will come closer to each other, it means that the volume will decrease. The volume will decrease down over there. And as the volume will decrease, what will happen? The density is going to be increased. Okay, as we are coming down, means as the temperature been taken down, or as we are cooling it, we will observe that the density increases as the volume decreases. Again and again I'm repeating this thing, because on the basis of this principle only we will be able to understand the concept of the anomalous expansion of water. Now let's discuss about the anomalous expansion of water. देखो हम लोगों ने अभी ये चीज समझा कि अगर हम लोग किसी भी मैटर को गर्म करते हैं, अगर हम लोग हीट सप्लाई करते हैं, अगर हम लोग हीट देते हैं, तो हीट देने से क्या होगा? हम लोग जैसे जैसे हीट सप्लाई करेंगे वहां पर हम लोग ऑब्जर्व करेंगे कि जो वॉल्यूम है, वॉल्यूम भी वहां पर बढ़ेगा। क्यों वॉल्यूम बढ़ेगा? क्योंकि पार्टिकल्स दूर जाएंगे, और जब वॉल्यूम बढ़ेगा तो हम लोग ऑब्जर्व करेंगे कि जो डेंसिटी है वो घटेगा, वहां पर वो घटने वाला है। अगर हम लोग इसका रिवर्स फेनोमेना करते हैं, अगर हम लोग इसको अपोजिट कर देते हैं, अगर हम लोग कूल डाउन करते हैं, अगर हम लोग ठंडा करते हैं, किसी चीज को ठंडा कर रहे हैं, तो उसके टेम्परेचर को हम लोग कम कर रहे हैं। तो जैसे जैसे हम लोग उसके टेम्परेचर को कम करेंगे तो पार्टिकल्स नजदीक आएगा। जैसे जैसे पार्टिकल्स नजदीक आएगा तो वहां पर वॉल्यूम जो होगा वो घटेगा, पार्टिकल्स के वॉल्यूम वहां पे घटेंगे, जिसके कारण क्या होगा, डेंसिटी जो होगा वो इंक्रीज होगा। तो जब हम लोग वाटर के साथ देखते हैं तो वाटर में ये फेनोमिना फॉलो होता है, ये दोनों ही फेनोमिना फॉलो होता है। लेकिन ये जो ड्रॉपिंग डाउन ऑफ टेम्परेचर यानी कूलिंग के समय हम लोगों को वहां पर एक अजीब सा फेनोमिना देखने को मिलता है, या एक अजीब सा सिचुएशन देखने को मिलता है बिटवीन 4 डिग्री सेल्सियस टू 10 डिग्री सेल्सियस, एंड दैट फेनोमिना इज ओनली नोन टू बी एज द एनोमलस एक्सपेंशन ऑफ water. So what does that means? What it is actually showing? So over here, what happens? Suppose, for example, you had taken water at 20 degrees Celsius. Suppose मान लो कि तुमने एक certain amount of पानी लिया किसी कंटेनर में और उसके तुमने मेजर किया उसके टेम्परेचर और तुमने उसके पाया कि टेम्परेचर इज 20 डिग्री सेल्सियस। नाउ इफ यू आर कूलिंग दिस, अगर तुम इसको ठंडा करते हो, then what will happen? Its temperature will fall down, say as it reached to 10 degrees Celsius. Now, after reaching to 10 degrees Celsius, what you will observe in the change in the volume? तुमको यहाँ पे particles के volume में क्या क्या difference मिलेगा? Obviously, you will find that the volume is decreasing. Now, as the volume is decreasing, you will observe that the density is going to increase. जैसे जैसे volume decrease करेगा, यहाँ पर density और बढ़ेगा। Now still you are cooling it, अभी भी तुम लोग उसको कूल कर रहे हो। Now from 10 डिग्री सेल्सियस, suppose for example it reached to 5 डिग्री सेल्सियस, वो और ठंडा हुआ, वो 5 डिग्री सेल्सियस पर आ गया। अभी क्या हो रही है, अभी भी तुमने ऑब्जर्व किया कि द वॉल्यूम इज डिक्रीजिंग, स्टिल द वॉल्यूम इज डिक्रीजिंग एंड द डेंसिटी इज इंक्रीजिंग, अभी भी डेंसिटी यहाँ पे बढ़ रही है। Now after this, still you are cooling this, and when it reached to 4 डिग्री सेल्सियस, जब ये 4 डिग्री सेल्सियस से पहुंच गया, अभी जो डेंसिटी है इसके इसके चेंज, वॉल्यूम में चेंज आया, अभी भी डेंसिटी में यहाँ पे चेंज आया, और इसी टेम्परेचर पे ही हम लोगों का एक्चुअल इंपैक्ट होने वाला है। इस टेम्परेचर के बाद जब हम इसको और ठंडा करते हैं, जब हम लोग 4 डिग्री पे पहुंच जाने के बाद इसको और ठंडा करते हैं, then we used to observe that where earlier my density was increasing, now instead of increasing it is decreasing now. अब वो बढ़ने की जगह पर वो घटने लगा। ये एक अजीब सा फेनोमिना हम लोगों को देखने को मिलता है, जहां पर कि हम लोगों ने पहले ऑब्जर्व कर रहे थे कि जैसे जैसे टेम्परेचर डिक्रीज हो रहा था वैसे वैसे वॉल्यूम भी डिक्रीज हो रहा था, जैसे जैसे वॉल्यूम डिक्रीज हो रहा था यहाँ पे डेंसिटी भी इंक्रीज हो रहा था। लेकिन जैसे ही हम लोगों ने 4 डिग्री के नीचे उसको और ठंडा करने का कोशिश किया, तो हम लोगों ने ऑब्जर्व किया कि यहाँ पर वॉल्यूम डिक्रीज होने की जगह पर वॉल्यूम बढ़ने लगा, और ये चेंज जो है इसके कारण जो डेंसिटी है ये भी यहाँ पे चेंज होने लगी, तो डेंसिटी और घटने लगी। इंस्टेड ऑफ इंक्रीजिंग द डेंसिटी ड्यू टू on cooling more than 4 degrees Celsius, we will observe that it is going to decrease its density, उसकी डेंसिटी अब घटने लग रही है। यही फेनोमिना जो है, ये फेनोमिना हम लोग ऑब्जर्व करते हैं टिल 0 डिग्री सेल्सियस एंड टिल इट इज इन द लिक्विड फॉर्म, वो लिक्विड फॉर्म में हो है अभी। तो इस पर्टिकुलर कंडीशन में ये जो 4 डिग्री से लेकर 0 डिग्री के बीच में जो ये कंडीशन आती है कि इवन ऑन कूलिंग वी ऑब्जर्व दैट दैट इंस्टेड ऑफ इंक्रीजिंग ऑफ द डेंसिटी डिक्रीजेस ओवर देयर, दैट इज कॉल्ड द एनोमलस एक्सपेंशन। सो व्हाई दिस हैपेंस बिकॉज ऑफ द अनइवन चेंज इन द वॉल्यूम, uneven pattern of change in the volume. That is the thing which used to cause the anomalous expansion, and that is the thing which we are studying over here. And this particular behavior been observed in water, and due to this particular behavior only we do observe that during the harsh winter in many places, the winter used to be very very harsh, and over there you will observe that the upper layer of the water body gets frozen out, but the the bottom layer, or at the base, you will find that the water is still in the liquid form, and all the aquatic life is able to survive over there. So it might be a condition of nature that which had created itself in such a way that it had supported the life, or it had to support the life. So if anomalous expansion would not be there, then it might possible that during harsh winter the whole water body would be frozen out. So if you had seen a frozen lake or pond, or a layer on a river, then it's not like that the whole water body got frozen out. It's only the upper layer of that water body which is frozen over there, and that is due to the anomalous expansion of water. And this anomalous expansion of water is due to the molecular arrangement. As we all know for this thing, that the molecules of water contains hydrogen and oxygen. So there is a bonding between hydrogen and oxygen. So because of the chain bonding between hydrogen and oxygen, so there is an energy level which used to change, and due to that only we used to observe that at 4 degrees Celsius or after 4 degrees Celsius, even though when we are cooling the water, we observe that instead of coming closer to the particles, or instead of coming closer of the particles start moving away from each other. So their volume increases over there. So that is the bond which is responsible to cause this anomalous expansion. So when we will study this anomalous expansion again in chemistry in class 11th, over there we will discuss on this thing when we will come across about the energy which is responsible to bind the oxygen and hydrogen bond over there. Okay, now let's move to the next topic. Over here we are going to discuss about the Hope's experiment. So Hope was a scientist who had performed an experiment, and with his experiment, he was able to establish the relation that the anomalous expansion used to take place. So in his experiment, he had performed with a very simple concept, and with that concept, he had established the thing that water used to contract, expand after 4 degrees Celsius instead of contracting. So what he had done, he had taken one glass container, where there were two holes at two different points. He had poured this water with a certain temperature. Say, as for example, the water's temperature was at 10 degrees Celsius or 15 degrees Celsius. And he had placed it with two thermometers. So right now here it is at 20 degrees Celsius. So instead of 10, I will take it as 20 also. So here, say as this water was at 20 degrees Celsius. So both the thermometers was showing that the temperature is at 20 degrees Celsius. Now this glass container has been covered with another glass container or a metric container, which was containing ice and salt. Okay. Ice and salt creates a certain situation where its cooling effect increases, means the melting point of ice decreases down rather than to 0 degrees Celsius. So it can create more, or it can absorb more heat. So because of that, he had performed it, or he had arranged that kind of thing over there. Now, when this ice with salt has been placed in between this one, what was going through over here? So say as for example, those particles which were near to this ice column, slowly they were reducing the temperature because this ice was absorbing heat from it. So as the heat was absorbed, the water molecules which were over here at the very beginning, slowly their डेंसिटी वाज इंक्रीजिंग. देखो, हम लोगों ने पहले ही समझा हुआ है कि जब हम लोग किसी भी कंपोनेंट को ठंडा करते हैं, किसी भी लिक्विड को ठंडा करते हैं, चाहे वो पानी क्यों ना हो, जैसे जैसे हम लोग उसको ठंडा करेंगे, पार्टिकल्स नजदीक आएंगे तो डेंसिटी वहां पर इंक्रीज होगी. तो जो सबसे पहले सिचुएशन में जो यहाँ पे सबसे पहले मॉलिक्यूल्स थे, ये क्या हुए, पार्टिकल्स नजदीक आने लगे. पार्टिकल्स जैसे नजदीक आने लगे, डेंसिटी बढ़ने लगा. जैसे जैसे डेंसिटी बढ़ने लगा, ये पानी नीचे की तरफ आने लगेगा, क्योंकि जैसे जैसे डेंसिटी बढ़ेगा, इट विल सिंक डाउन ओवर देयर ऑन द बेसिस ऑफ द प्रिंसिपल ऑफ फ्लोटेशन. ये जैसे जैसे नीचे आएगा, हम लोग ऑब्जर्व करेंगे कि जो बी थर्मोमीटर है, मींस जो सेकंड थर्मोमीटर है, इसका टेम्परेचर गिरेगा. ठीक है, इसका टेम्परेचर गिरने लगा। सो 20 डिग्री सेल्सियस था, सपोज ये 15 डिग्री सेल्सियस पे पहुंचा, फिर ये 12 डिग्री सेल्सियस पे पहुंचा, साइमल्टेनियसली गॉन टू 8, 6, 5 एंड 4, ये 4 डिग्री सेल्सियस तक पहुंच गया। अभी तक हम लोग ऑब्जर्व करेंगे कि जो ऊपर वाला थर्मोमीटर है ये अभी भी 20 डिग्री सेल्सियस ही हम लोगों को दिखा रहा है। अब जब नीचे वाला थर्मोमीटर 4 डिग्री सेल्सियस पर पहुंच चुका है, then after that we will observe this thing that it got constant, ये अब यहां पे कांस्टेंट हो जाता है। then this a thermometer starts slowing down, that its temperature is decreasing। अब ऐसा क्यों हो रहा है? क्योंकि अभी भी तो आइस तो यहाँ पे मौजूद है, ये इधर वाली जो पानी है इसको वो ठंडा करते चले जा रहा है, तो ठंडा करते चले जा रहा है तो डेंसिटी इंक्रीज होनी चाहिए, वो और नीचे आना चाहिए। बट इंस्टेड ऑफ कमिंग डाउन, what happens, the particle had started moving in the upward direction। why? Because after reaching to 4 डिग्री सेल्सियस, यहां तक के पानी का जब टेम्परेचर 4 डिग्री सेल्सियस से पहुंच जाता है, इसके बाद पानी की डेंसिटी बढ़ने के जगह पर वो घटने लगती है, और इसी के वजह से ये ऊपर की तरफ बढ़ती है। अगेन according to the law of flotation, what we had done in our previous chapter। so as it is moving in the upward direction, what we will be observing that this a thermometer will reduce down its temperature। यहाँ पे a thermometer जो है ये अपने टेम्परेचर को धीरे धीरे करके नीचे कम करती चली जाएगी। और इसी प्रिंसिपल के लिए, इसी प्रिंसिपल को यहाँ पे समझते हुए हम लोग ये देखते हैं, या फिर ये कह सकते हैं, yes, water used to have the anomalous expansion, and due to this, after 4 degrees Celsius or after reaching to 4 degrees Celsius, instead of increasing its density starts decreasing। उसकी density वहां पे घटने लगती है because of the change in the volume over there, and due to this only we are observing that this condition is causing over there। So that was the Hope's experiment, by which he had explained that how we can identify or how we can understand the anomalous expansion goes on। And this anomalous expansion can be observed in nature also, and because of that only, as I said earlier, that during the harsh winter, the water bodies remains in the same temperature, or can able to avoid to get frozen down from the कंप्लीट वन। तो जब हम लोग देखते हैं कि जो एटमॉस्फेयर का टेम्परेचर है, एटमॉस्फेयर के टेम्परेचर के घटने के साथ साथ जो ऊपर वाला पानी है, जो कि जैसे वाटर बॉडी का जो अपर लेयर है, वो अपना टेम्परेचर कम करता है, और वो जैसे जैसे अपना टेम्परेचर कम करता है वो नीचे की तरफ जाती चली जाती है, क्योंकि एट द बिगनिंग इट्स इंक्रीजेस इट्स डेंसिटी, वो डेंसिटी इंक्रीज करती है। और जब पानी का टेम्परेचर 4 डिग्री सेल्सियस से पहुंच जाता है, तब वहां पे डेंसिटी इंक्रीज होने के बजाय वहां पर डेंसिटी डिक्रीज होती है, जिसके कारण क्या होता है, पानी ऊपर की तरफ आने लगती है, वो ऊपर की तरफ आने लगती है। और जैसे जैसे वो ऊपर की तरफ आती है तो टेम्परेचर और घट ही रहा होता है। तो ऊपर के लेयर में हम लोग ऑब्जर्व करते हैं कि आइस का एक कॉलम बैठ जाता है, लेकिन नीचे की तरफ जो अभी भी पानी पहले के मुकाबले में 4 डिग्री सेल्सियस या 5 डिग्री सेल्सियस पर है, वो ज्यादा कंपैरेटिवली डेंसर है, जिसके कारण वो नीचे की तरफ ही रह जाती है। तो जो वाटर बॉडीज का जो बॉटम हिस्सा है, या फिर उसका जो निचला वाला हिस्सा है, वहां पर तो हीट या कंपैरेटिवली हॉट वाटर हमको मिल जाएगा देन कंपेयर टू द अपर सरफेस। तो जो जितने भी वाटर बॉडी फ्रोजन फॉर्म में हम लोगों को देखने को मिलती है, वेदर इट इज द लेक और पॉन्ड, एनीवेयर ड्यूरिंग द विंटर सीजन, वी यूज्ड टू ऑब्जर्व दैट द अपर लेयर ओनली गेट्स फ्रोजन आउट, बट द बॉटम और द बेस रिमेन्स कांस्टेंट। So this was the thing which we had to understand. So now let's move to some other things which we have to understand over here. So there are some consequences of the anomalous expansion also, that during the winter season we do used to observe that in some places the water pipes the water pipes gets blast out. So that is because of the changing in the density. So as there is a changing in the density of the water which is present inside the water container, due to the change in the volume over there with the change in the temperature, we do observe that they used to exert an extra amount of pressure on the pipes, and those places or those points where there is a weak point from from there the pipe gets blast out. So these are the things which we need to understand regarding the anomalous expansion of water in this particular chapter. Now we will come to the second part of this chapter where we have to discuss about the energy flow. When we are talking about energy flow in physics, then we have to understand this thing that we are actually talking about heat energy, because all the organisms, different kinds of organisms used to survive on the basis of the food they used to take, and the food which gets consumed in the body, that is also in the form of heat, and the heat energy been released out in their body, and because of that heat energy they are only able to survive. So when we are observing the energy flow, we can say that there is a continuous flow of heat energy among the different organisms. So sun is the primary source of any kind of energy that we used to have on the earth. So from the sun, the another primary source which produces the food, or the which produces the energy, that is the plants, the green plants. They perform the photosynthesis process, and they produces the food, hence they are called the producer. And by consuming the food from there, um, uh, different organisms are able to survive on the earth. So basically the plants are the producer who produces the energy, and through them the different organisms used to receive the energy. And this is a linear process which used to go from one to another, and with the different layers of organism or different layers of the column, we can divide them into primary consumer or secondary consumer. This thing you all had studied in biology, so I don't think that I have to explain more in this one, because you all know about the primary producer as the green plants, and through them the primary consumers, which we used to say for the herbivores, and then from them the secondary consumers or the tertiary consumers as the carnivores or omnivores used to receive energy, and the energy from the sun has been transmitted from one to another. Now, over here, this is a graphical representation where you can observe that how energy can be transmitted from the sun to the producer, then to the consumer, and how it can be decomposed and then again returned back to the producer. So as you all know for this thing that living organism, basically, if I will say for the plants, different kinds of plants who are the producer, they receive the sunlight, they produce the food. With the food, what they produces, it been taken by the consumers, means different kinds of organism used to take that food, and they used to survive. And when they die, they decomposes, and on decomposing, they return back the nutrients in the nature, which returns again to the producers. So the cycle can be transmitted, or the cycle can be able to move ahead and ahead. And like this only, we used to observe that how the energy or the heat energy which has been supplied from the sun has been transmitted from one organism to another organism. And this can be understood with the food chain on the food wave also. So when you go and study about the food wave or the food chain, you can understand that the energy cycle is going on and on and on, and because of that only energy can be transmitted from one to another. And this is the phenomena of nature. This is how the nature used to go on, and this help us to continuously move on with the nutrient cycle. And with the nutrient cycle, we are able to create, or we can be able to make a balance on the earth, where all the organism and all the organic material can be able to exchange their nutrients among each other to maintain the balance. So these are the things which you had already studied in biology. Now over here, before we go to some other topic, one of the things which we need to understand, the application of the law of thermodynamics. Now, as we know for this thing that energy can be created nor be destroyed, but it has a tendency that it can be transmitted from one to another. So when we are talking about the first law of thermodynamics, that states the same principle over here, that according to the first law of thermodynamics, it can be said that energy can be transmitted from one form to another form. And while we are doing so, then we used to observe that the total sum of the energy in the system remains constant. But with that one more thing we have to understand, that while one form of energy gets converted to some other form of energy, then we do observe that some unuseful form of energy is also present over there. And that unuseful energy, or that unuseful form of energy is mostly observed as in the form of the heat energy. But it is not necessary that always at every situation we will observe the heat energy, but in most of the situation we do observe it as heat energy only. But in some other form it can be like light energy also, such as a very common example I will give for this thing, that as I am recording this class over here right now, so we are having winter season. So in the winter season we do have a heater, and when we are lighting up a heater, then we do observe that the electrical energy which has been consumed over there, that electrical energy is mainly producing the heat energy through the rods, but a little bit amount of energy gets converted into the light energy also. So suppose for example 100 joule of electrical energy been consumed, so we will not be obtaining all 100 joule as heat energy. We will observe there is some other flow of energy or some other form of energy also which gets used unuseful form or in unuseful pattern, which escapes out in the nature. In the same way, there are numerous examples where you can see that when one form of energy is converting to some other form of energy, then some unuseful form of energy is also present over there, and mostly it is in the form of heat energy, such as for example while you are riding your bicycle, at that time the friction force which is going to act between the wheel and the road, that is leading to heat energy. So that is also one of the example where you can see or you can observe that how while the conversion of energy is going on, then heat energy produces over there. Now, let's move to the sources of energy. What are the different sources of energy? So, this is a very common thing which you had studied in your junior classes also, that the sources of energy has been classified into the form of a renewable energy sources and non-renewable sources of energy, where we say the renewable sources as non-conventional sources and the non-renewable sources are said to be as conventional sources of energy. So that is depending on their uses. जब हम लोग रिन्यूएबल सोर्सेस के बारे में बात करते हैं, तो हम लोग कहते हैं उस तरह के फॉर्म ऑफ एनर्जी जिनको कि हम लोग बार बार ऑब्टेन कर सकते हैं या एक लंबे समय तक ऑब्टेन कर सकते हैं, लेकिन वो चूंकि हम लोग परंपरागत तरीके से इस्तेमाल नहीं करते हैं, इसीलिए उसको हम लोग नॉन कन्वेंशनल सोर्सेज ऑफ एनर्जी के बारे में बोलते हैं। लेकिन जब हम लोग बात करते हैं नॉन रिन्यूएबल सोर्सेज ऑफ एनर्जी, तब हम लोग आ जाते हैं कन्वेंशनल सोर्सेज ऑफ एनर्जी, क्योंकि इसी को हम लोग मेनली इस्तेमाल करते हैं। ज्यादातर जगहों पर हम लोग इन्हीं का इस्तेमाल ज्यादा से ज्यादा करते हैं। तो रिन्यूएबल सोर्सेज से हम लोग स्टार्ट करते हैं, क्योंकि ये हम लोगों का फ्यूचर माना जा रहा है और हम लोगों को इसको ज्यादा से ज्यादा प्रमोट भी करना चाहिए, क्योंकि इससे हम लोगों की धरती पर बहुत सारे बेनिफिट्स हो सकते हैं। जब हम लोग सोलर एनर्जी के बारे में बात करते हैं, तो हम लोगों को ये पता होना चाहिए कि हम लोग उस एनर्जी के बारे में बात कर रहे हैं जो कि हम लोगों को कई 100 सालों से पहले से मिल रही है, और ये हम लोग मान सकते हैं कि अगले कई 100 सालों तक हम लोगों को एनर्जी मिलती चली जाएगी। दैट इज द एनर्जी फ्रॉम द सन। सो आवर सन इज द मेजर सोर्स ऑफ लाइट और हीट ऑन द अर्थ। हम लोग की धरती पर अगर देखते हैं लाइट और हीट के लिए मेजर सोर्स के रूप में अगर देखते हैं, तो सोलर एनर्जी एक इंपॉर्टेंट फॉर्म ऑफ एनर्जी है, और इसको हम लोग अगर यूटिलाइज कर सकते हैं अपने अपने किसी भी काम को करने के लिए, तो ये हम लोगों के लिए बहुत ही अच्छा हो सकता है। दिस एनर्जी कैन बी यूटिलाइज फॉर कुकिंग, we can use it for doing any kind of transportation work, any kind of communication work, any other kind of work we can perform it very easily. So there are very various advantages of these kind of solar these kind of energy, such as for example for the solar energy. अगर हम लोग सोलर एनर्जी के लिए देखते हैं तो सबसे इंपॉर्टेंट और सबसे मेन जो इसमें आ जाती है ये है क्या कि हम लोग रिन्यूएबल सोर्स के ऊपर डिपेंडेंट है। हम लोग सोलर एनर्जी पे रिन्यूएबल सोर्स के ऊपर डिपेंडेंट है। बिकॉज ऑफ दैट वी आर नॉट क्रिएटिंग एनी पॉल्यूशन। हम लोग इन्वायरमेंट में किसी भी तरह के कोई पॉल्यूशन क्रिएट नहीं कर रहे हैं। इट इज जीरो एमिशन कंप्लीटली। इट इज जीरो एमिशन मींस दैट इट इज नॉट प्रोड्यूसेस any carbon wastage out. Next, we can use it for a very long period of time. It requires minimum maintenance, but yes, there are some disadvantages also, such as for example, the plotting of solar panels are still very costly. But if we go for it or if we are promoting it, then we will be able to use this form of energy for a very long period of time. And as an Indian, we should be proud for that India is the leading country in the world to produce the solar energy, where we are having different solar plants in our country, where we are producing thousands of megawatt of electric current. So that is as I said in the beginning, that it is the future of our country or the world for the energy requirement. The next form of energy which we are going to discuss over here, that is the wind energy. Wind energy is the energy which we are obtaining due to the kinetic energy of the wind. So we are actually we are actually harnessing the kinetic energy of the wind, and we are doing so in the windmills, and over there we are producing the electricity. Even though India is not so very wind-friendly country, means throughout the year we don't have an even pattern of wind, but then also we are right now the second largest country in generating the wind power. So as again, there are so many advantages over here. The very basic advantage which I will talk about again and again, that it is pollution free. It is not creating any kind of pollution. So we can use it for a very longer period of time. But yes, there are limitations also, that it is still very costly. It is among the costliest renewable sources which we use in our day-to-day life. And second thing is that this is not be able to place, or this is not able to be constructed at every place. We have to place it for those places only where year long or for a very longer period of time throughout the year we observe at least of a wind speed of at least 15 kilometers per hour or nearby to that one. Because if it is very much windy, then also it is not going to work, and if it is very slow, then also it is not going to work. So this is also we need to remember. Now over here we can see this thing, that we are talking about the electricity produced by the tidal energy. So here you can see that how tidal energy is useful to produce the electrical energy over here. So tides are continuously generated in the sea, or in the sea coastal places. So when the tide is going on, then with that also we can use the kinetic energy over there to run the turbines, and by running the turbines we can produce electricity. So this is comparatively more cost efficient than compared to the wind energy, because over here we can produce the electrical current with a large amount for a very long period of time. Because we have in India, if I will say, we have a very long coastline, and tides are a continuous phenomenon. It continuously goes. So while the tide is coming in or going out, we can produce the electricity, and with that one we can use it for a very longer period of time. So at least those villages which are nearby to the coastline, there we can produce the electricity, and there we can use this kind of electrical energy sources. Next, one of the very important and very common form of energy producing component from the nature, that is the hydropower plant. So in the hydropower plant, we use electricity to be produced by the flow of water. Again, the kinetic energy of water is used to generate the electric current. So over here in the reservoirs or in the dam, we used to store water, and then that water is allowed to be fall through from a height, or we can pass it through a tunnel where it goes in such a way that it makes a rotation in the turbine. And as the turbine used to rotate, the shaft which is connected through the turbine makes the motion in the generator, and in the generator the electricity can be produced, and this electricity can be transmitted to far places, and it can be utilized for a longer period of time. Again, this is nature friendly, but yes, there are some demerits. Again, over here, when we go for the planting of hydropowers, we used to observe this thing that we are destroying the nature. Basically, we can say this thing that a part of nature has been destroyed over here. क्योंकि देखो, जब डैम्स को कंस्ट्रक्ट किया जाता है तो जो माउंटेनी एरियाज होते हैं तो उसमें बहुत सारे पेड़ पौधे जीव जंतु जो हैं वो वहां पर सबमर्ज हो जाते हैं, वो पानी में डूब जाते हैं। तो वो जो एरियाज हैं उन एरियाज में वो लिविंग ऑर्गेनिज्म की डेथ, एक तो वो एक प्रॉब्लम है। दूसरी एक प्रॉब्लम है कि जब वो डिकम्पोज करते हैं तो वो मीथेन गैस प्रोड्यूस करते हैं, और ये मीथेन गैस जैसे जैसे एटमॉस्फेयर में जाता है वो हम लोगों के एटमॉस्फेयर को पॉल्यूट कर देता है। तो ये भी एक प्रॉब्लमेटिकल कंडीशन हम लोग देख सकते हैं। बट इवन ऑल फॉर ऑल दीज थिंग्स, then also we are using this hydropower for a lot of benefits also, because when we are talking about hydropower, जब हम लोग हाइड्रोपावर के बारे में बात करते हैं तो सिर्फ और सिर्फ इलेक्ट्रिकल एनर्जी के बारे में ही नहीं बात होती है। ये जो पानी आगे की तरफ फ्लो हो जाएगी, जब पानी को आगे की तरफ हम लोग फ्लो करवा देंगे, then this water can be used for irrigation purpose also। खेतों में इसको इरिगेशन के लिए भी इस्तेमाल किया जा सकता है। So we are using it for two different benefits, okay, but still its demerits are there. With that one, we have to think for this thing, that how we can overcome for those demerits, such as for example one very innovative idea which came in India, that we are plotting the floating solar panels. As I said, that methane gas is released, so the environment gets damaged. So the scientists and the engineers have thought for that, how can we save the nature? How can we fight against those methane gas which has been thrown in the nature? So we can't take all those methane gas, but we can be able to use that resource in a better way so that it can produce some more benefit for us. So over here we had used it as a floating panel. So floating solar panels are there which can produce the electricity also, and this will help us to do different kinds of work. So this is also one of the very important common thing which as a natural resource which we use in our day-to-day life. Now we come for the biomass. So biomass is again one of the very popular form of energy sources which are getting developed in nowadays, where we are actually decomposing the organic materials. We are putting all the organic materials in a pit, and we are decomposing these materials. And as these materials gets decomposed, methane gas been produced over here. Now methane gas is a very good form of a fuel. So that is CH4. CH4 is the methane gas, and this can be used as a very good fuel. So biomass or biogases can be used as a very good form of energy in our future, because we all are producing the organic waste. If those organic waste can be stored, and by decomposing, if we are able to produce the methane gas, or even though by combining them we can go for the ethane or ethanol also. So these all forms of fuels can be utilized, even though they are carbon components. These are also carbon components. If we are burning this, then we are actually putting carbon dioxide or carbon monoxide in the nature. But this is one of the fuel which we can obtain by all those kind of raw materials or the waste material which we generally used to throw out of our houses. So even if we are wasting them, else than to waste out, if we are using it to make fuel, then it can be a good resource. We can use it for a longer period of time. And not only for that, the waste material which is left out after the production of the methane or the ethanol, all the materials can be utilized again as a manure. So in the fertilizer, in the perspective of farming, we can use this thing again. So in the field, if we are putting it, then it will be acting as a natural fertilizer. So that is also a benefit of using biomass or biogases. Now, let's move to the nuclear energy. Nuclear energy, one of the very important discovery which human being had done, and this is very dangerous also. Nuclear power energy is actually a non-renewable resource because it is depending on the uranium and thorium, which is again a natural resource, and it is limited in amount. But we consider the energy which we used to produce by nuclear energy that as a renewable source, because when we compare the amount of energy which we can obtain by consumption of nuclear energy with comparison to the conventional form of energy, such as, for example, if we compare the amount of energy that we can obtain by 1 kg of uranium with the conventional thermal power plant where coal been burned to produce electricity, then we observe that it's around to be 1 kg of uranium. 1 kg of uranium will give us that amount of electrical energy or that amount of energy, which will be approximately equals to 25 lakh kg of coal. So if we are burning 25 lakh kg of coal, the amount of energy which we are going to get over there, that can be obtained by the consumption of 1 kg of uranium. Hence, even though it's completely dependent on the natural resource, which is limited on the Earth's crust, we can obtain it or we can use it for a very longer period of time. Hence, this has been considered to be as a renewable source of energy, and most of the developed countries are dependent on the nuclear energy for their electrical purpose or electricity which they used to produce. India is also moving ahead in going across the nuclear energy, but as I said, that every good thing has so many different bad things also. So nuclear energy also has some drawbacks, such as, for example, it can cause or it can create a huge amount of radiation. So if there would be any kind of mishappening, then it is going to produce a lot of amount of radioactive waste as well as radioactive radiation, which will lead to damage to thousands and millions of people. So that's why we are not able to construct more and more nuclear energy, because many people used to oppose that one, and there must be some specific restrictions which we have to follow for the nuclear energy. And with that also, we don't have that much of modern technique and technology by which we can produce or we can create our own nuclear reactor. We still need to take the help from the different developed countries to give their reactors, or they give their technologies, and on the basis of that we can produce our own, or we can borrow the nuclear reactor from them only. So these are the things which we need to discuss or we need to remember for the nuclear energy. We will discuss about the nuclear energy in class 10, where we are going to discuss about the nuclear reaction, where the nuclear fission and fusion process used to take place, that we will see in class 10's modern physics chapter. And one more thing which you need to remember over here, that the nuclear reaction which is going on still, that is the nuclear fission process. Okay, so where we used to break down a heavy component into a smaller component, is the heavy nuclei used to be splitted into smaller components. So uranium used to be broken down into smaller components by bombardment of the nuclei in there. Sorry, neutrons in that one. So we will discuss more on this thing, that how this reaction is going on. So over here you can see that I have given the construction of that splitting of the uranium, which you have to see. And as I had discussed about the advantages and disadvantages, so both are over here. You can pause the video and you can go through all the points. Now, as we all know about that when we go for the conventional sources of energy, we do have fossil fuel. So fossil fuels are the very common form of energy and the conventional form of energy which we do obtain from the fossils. And with this, we obtain, when I talk about fossil fuel, then I'm talking about coal and petroleum, both the things. And petroleum's been obtained by the decomposed fossil of the aquatic animals and plants. Whereas when we talk about the coal, then we talk about the fossils which has been constructed by the trees. So when trees got decomposed and they converted into the fossil, they form the coal. Whereas when the petroleum component, when we are talking about, then we are talking about that those are the materials which been done by the fossil of the aquatic plants and animals. So we had discussed these things in our previous classes. You all had discussed these things in your physics as well as in chemistry. You know for this thing that the crude oil can be purified by performing the fractional distillation process. So when the crude oil been purified, then from there we can take the petrol, diesel, kerosene, white oil, and different kinds of other gases. We can obtain it. And coal is a very common thing which can be utilized directly. So we need to dig the place. If we get the coal in the under the earth's crust, we have to use it directly. But the crude oil, means the petroleum product, need to be extracted. So when we are using all these kind of conventional sources of energy, then we are actually harming our nature. We are creating problem to our nature. We are emitting large amount of greenhouse gases in the nature, due to which what happens, that our average temperature is continuously increasing. And while we are talking about that there is an increase in the average temperature, it means that it leads to global warming, which has so many different consequences, such as, for example, the melting down of the glacier, the continuous change in the weather. There are so many different things which we are continuously observing due to the large amount of greenhouse gases. So in today's modern day, we are consuming the fossil fuels in a very large amount, and because of that the carbon footprint is increasing very high amount. Carbon footprint is the amount of carbon that emits out by any country in a particular year. So if you are completely dependent on the natural fuel only, such as, for example, petrol, diesel, coal, then we will continuously emit carbon dioxide, carbon monoxide gases in the atmosphere, and it will lead to the global warming. So if we need to save our earth, if we need to keep our earth in a greenish form, if we want to keep our earth in a proper way, then we all need to work together. We all need to fight against the condition that leads us to move towards the fossil fuel. We need to move away from the fossil fuel. We need to move towards the renewable sources of energy. If we will all try to do, then one day there may be a possibility where we can be able to emit a minimum amount of greenhouse gases. I'm not saying that stop using the fossil fuel, stop using all the kinds of gadgets and equipments, but yes, if we will go for wise condition, if we will have a sustainable behavior, then we will be able to sustain for a longer period of time. So this was the chapter which we had to discuss over here, and all the things which we need to discuss in this chapter I had been provided in this chapter. You all can go through all these notes. Wherever you need to go for the note down of the points, you can pause the video and you can see for all these things. So all the benefits what we can obtain from the nature, that is there, as well as we need to remember what all benefits we can give to our nature. So with this particular point only, I'm ending up this class. So thank you everyone. Bye. We will see again in the new chapter.